Finding points of inflection. If the ordered pair C, f of C, is a point of inflection on the graph of f, then either the second derivative f double prime of C is equal to 0, or f double prime of C does not exist at x equals C. For an example, let's determine the points of inflection and discuss the concavity of the graph at f of x equals x to the fourth minus 4x cubed. First, we need to take the second derivative of f. Our first derivative, f prime of x, is found by using the power rule. So we have 4x cubed minus 12x squared. The second derivative, f double prime of x, using the power rule again, we have 12x squared minus 12x. And I'm sorry, not 12x. Power rule, we bring the 2 out front, that's 24. 2 times 12. Next, we'll factor the second derivative. So we have 12x times x minus 2. If we set each factor equal to 0 and solve for x, clearly 12x equals 0 becomes x equals 0. And x minus 2 equals 0 becomes x equals positive 2. Since points of inflection can occur where the second derivative is equal to 0 or where the second derivative does not exist, I know that my possible points of inflection occur at x equals 0 and x equals 2. Setting up my number line, plotting those possible points of inflection, 0 and 2. We'll choose some test points. Here I would choose negative 1, 1, and 3. Evaluating f double prime of negative 1 by plugging it into the second derivative gives us a value greater than 0. Since 12 times negative 1 squared minus 24 times negative 1 equals a positive number. When f double prime of 0 is evaluated, it turns out to be negative, or less than 0. And when we evaluate f double prime of 3, our last test point, that turns out to be greater than 0. So for our first test point, f double prime of negative 1, rather of negative 1, that's concave up. F double prime of 0 gives us a result that's concave down. And our last piece, f double prime of 3, is concave up. Now, although a point of inflection can only occur at a 0 of the second derivative, it is possible for the second derivative to be 0 at a point that is not a point of inflection. However, in this case, x equals 0 and x equals 2 are both points of inflection, And we know this since we have concave up, concave down, and concave up, where the graph is changing direction. And in those places where the graph changes direction, an inflection point can be found. This concludes our example, and we'll see you next time.